In a world that's just full of uncertainty, how can we possibly get a handle on what's going to happen next? Well, it turns out one of the most powerful ways is through simulation, basically creating these digital models to play out future scenarios. Today, we're going to dive into two really powerful but very different ways to do just that.
I mean, just think about it for a second. You've got a factory that wants to minimize defects, a bank trying to shorten those awful wait times, or maybe a company launching a brand new product and they're trying to forecast cost. All of these things involve these super complex systems and a whole lot of randomness. So, how do you make the right call? Well, the answer is you simulate the future before it even happens.
All right, here's our game plan. First, we'll get to know Monte Carlo simulation, which is the absolute master of what-ifs. Then we'll meet its cousin, Discrete event simulation, a tool that's all about the flow of time. After that, we'll put them head-to-head to really see the difference. And we'll finish up by figuring out which tool, or maybe even a combination of both, is the right one for the job.
So first up, Monte Carlo simulation. And yes, its name comes from that famous casino, and for a really good reason. This whole method is about understanding outcomes by basically rolling the dice millions of times, just digitally. The idea actually came from a mathematician, Stanislaw Ulam, back in the 1940s. He was stuck trying to calculate the odds of winning a game of solitaire. Instead of crunching the impossible math, he just thought, why not just simulate playing the game hundreds of times on a computer and see what happens? Genius.
So what is this thing exactly? At its heart, Monte Carlo is all about tackling uncertainty in your inputs. You might not know the exact cost of a raw material, right? But you know it's probably between, say, $10 and $15. You don't know exactly when a project will finish, but you have a pretty good idea of the range. Monte Carlo just runs thousands and thousands of simulations, picking random values from those ranges every single time so you can see the entire spectrum of what could possibly happen. The process itself is actually surprisingly straightforward. First, you define the range for your uncertain variables, like that material cost we talked about. Second, you just randomly pick values from that range. Third, you run your calculation, like your project budget, using those random values. And then, this is where the magic happens. You do this thousands of times, and then you aggregate all the results. The cool part is, it doesn't give you one single answer. It gives you a probability distribution of all the possible answers. To really make this click, let's look at a classic example. Just imagine a square, and inside that square, you draw a circle that fits perfectly. Now, if you start throwing darts randomly at the square, some are going to land inside the circle and some will land outside, right? Well, it turns out the ratio of darts inside the circle to the total number of darts you threw is proportional to the ratio of the areas. And since that area ratio involves pi, you can actually get a pretty good approximation of pi just by counting darts. That is the beauty of Monte Carlo, turning pure randomness into a surprisingly accurate answer. Okay, let's completely shift gears and talk about our second method, discrete event simulation, or DES for short. Now, if Monte Carlo is like rolling the dice, DES is more like building a digital twin of an entire process. Think a factory floor, a hospital emergency room, or even a fast food drive-thru, and then hitting the fast forward button to see how it performs over time. The key thing to grasp here is the simulation clock. Unlike a real clock, it doesn't just tick away second by second. Nope. It jumps from one important event to the very next one. A customer arrives, bam, the clock jumps. A patient is seen by a doctor, bam, another jump. A machine on the assembly line breaks down, jump. It completely ignores all the dead time in between, which makes it incredibly efficient for modeling these long processes that can unfold over hours, days, or even years. And to really get what DS is, it helps to see what it's not. Let's compare it to continuous simulation. Think about modeling the flow of water in a pipe. That's continuous. The state is changing constantly. DS is totally different. It only cares about those specific, discrete moments in time when something actually changes. The focus is all on the events, not the steady march of time itself. The engine that drives a DES model has a few key parts. You've got the system state, which keeps track of stuff like how many people are in line. You've got queues, which are literally just the waiting lines. But the real heart and soul of it is the simulation clock and the event list. The event list is kind of like a future calendar, telling the clock exactly which event to jump to next. So this brings us to the main event. We have one method that's all about random inputs, and another that's all about time and flow. So how in the world do you know which one to use? Okay, this is it. This is the crucial takeaway. It all boils down to this one question. Are you trying to find the best settings for your current process? Or are you trying to fundamentally change the steps of the process itself?
Getting this distinction is everything.
Let's break it down. Here's the difference in a nutshell. Monte Carlo is focused on parameters and settings. It gives you a static, sort of timeless view because each simulation run is independent of the others. It's asking, given all the uncertainty in my inputs, what's the full range of possible outcomes? On the other hand, discrete event simulation is all about the process and the steps. Its view is dynamic. It's all about what happens over time. It asks a totally different question. Where are the bottlenecks in my system, and how can I redesign the flow to fix them? But here's the thing, it's not always versus. In fact, the real power often comes when you use them together. It's about picking the right tool for the right part of the problem, and sometimes that means having them team up. So, when do you grab Monte Carlo from your toolkit? You use it when your main challenge is just quantifying uncertainty in your parameters. Think about project risk management. What's the probability this project goes over budget? Or financial modeling. What's the potential range of my return on an investment? These are all questions about the impact of uncertain settings.
And when does DES get to be the star of the show? Well, whenever you're dealing with systems that are all about flow, queues, and resources. Optimizing checkout lines at a supermarket, redesigning a factory workflow to get rid of delays, planning a whole supply chain, these are all problems about the process.
And here is a perfect example of how they create some real magic together. Imagine a factory. You could use a Monte Carlo simulation to figure out the absolute perfect optimal curing time for a product in an oven to minimize defects. That's a settings problem, right? But what if there's a huge bottleneck at the very next station on the assembly line? Your product could get stuck in that oven for way too long, ruining it, even if your setting was technically correct. You need discrete event simulation to model the entire factory process to make sure the line can actually handle that optimal time. See how they work together? Now, check this out. This is a fascinating real-world result that just shows how mind-blowingly powerful simulation can be. A study looked at the multiple line queuing system at McDonald's, where each cashier has their own line. The average wait time? 106 seconds. But then, using DES, they simulated what would happen if McDonald's switched to a single-line system, like you see at a bank, where one line feeds all the cashiers. The result? The average wait time dropped to just 11 seconds. That is nearly 10 times faster. It's the perfect example of how simulation can completely shatter our intuition and reveal these massive opportunities for improvement we'd never see otherwise. So there you have it, 2 incredible tools for peering into the future. Monte Carlo for understanding the real impact of uncertain parameters, and discrete event simulation for redesigning and optimizing complex processes. They give us a way to experiment, to learn, and to make way smarter decisions without any of the real-world cost or risk. So the only question left is, what will you simulate first?